with any piece of equipment at all, always start with the power supply, without fail. That's gone bright, but it's dimming off gradually. Okay. Now if I was to do that, like that, we see the heaters coming up. These are Osram valves, Z77, that one L Summit there. That one over there, by the way, is an oscillator, it is a rectifier valve. So that's where we start looking, okay? So I just look and see what and where and how, you know, but there don't seem to be any. Doesn't seem to be anything happening at all, so I don't know really, but so onto its side, heavy this thing actually, so onto its side it goes again, like so, okay, and it's down here, the valve in question, so let's have a think and see, and also why are these off? There's some wires off down here. I'll just turn it around so you can see, okay? There you are. The valve in question is up here, and why are they off? First question. There are quite a few passages that need to be changed for obvious reasons. Yes. So yeah. Anyway, just very quickly, what I will do is have a quick look around and see if there's anything anywhere, because, well, there should be. So let's see if there is, shall we? Nothing, nothing, no. 103 volts of that, I think that is there. Negative, okay. Okay, well, something anyway, but not a lot. Round here, it's like there's nothing by the looks of it. There's nothing in that at all. How about this one? Okay. How about now? With the heater, with that off, and see if anything comes up. Three volts, okay. That's something. 3 volts. Nothing. 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 And nothing. Okay. Over here, the same applies. Okay. 3 volts. 3 volts. Nothing. How about these caps here? Nothing. 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 Let's have a look on the AC. There's still nothing. Okay, so that suggests to me that there's absolutely nothing. Okay, so that therefore takes us back to the 6x4 or whatever it is on this this particular piece of equipment. It's this over here. I'll just turn it around again so you can see. This side here, okay. Okay. Let me see that, can you? How about that? This one here, at the top here, is a 6x1. So's that one actually as well. So there's two rectifiers on this as well. So I don't really know, but what I will do therefore, is plug this thing back on like that, for so with the meter like that, and see what we find round here. That seems okay. That seems okay. Let's go over here. That seems okay there actually. A bit low, but that's due to probably capacities failing. That says no. That says 160 volts, but that's not correct or anything. That's one limit. No, it's this actually. So these are probably the two that need to be changed before I go any further with it. What are they? They are 8 microfarads and 8 well, I've got 10. They'll do just fine. So I'll change a couple of 10s in there and look at where they go, because they don't seem to go anywhere. Is that going to that? That's warm there actually, that. Okay, I think with this we will need a circuit diagram, so I'll have a look and find one. The unit is an EMI oscilloscope, model number, go in so we can see again. It's on the back of the unit, so hang on. It's an EMI oscilloscope type WM1. Okay, so I'm now going to go online and try and find information I can about this scope before I go any further with it. Here's part of the circuit of the units involved here. The reason why I got this part of the circuit up off the manual, which is on my phone here, is because with anything like this, it's new, you always start with the power supply side of it every time. Okay, that transformer there has a number of 6.3 volt windings for the valves, and a lower current high voltage rating here for the HT, like many transformers of this type do. But this one's a bit different because of these. This is a voltage doubler circuit, similar to what I get in TV sets with triplers and quadruplers. It's the same sort of circuit, yeah. And it goes on to the middle and the end like that. That goes to deck up here, like that. I put it this way around so that you can actually see that part of it, you know. So now the two capacitors there, and then of course it goes along here through L3, which is just here. I'll sort that in a sec. Okay, and then to the rest of the set. Okay, now the valves are, I'll shift that. The valves are here, 6 and 5, okay, and L3 is this here. Okay, this here is L3. Okay, now before we go any further with this, we'll have a few basic checks. Anything here that's dead, for many people, would mean the end of the unit, but this is me we're talking about here, and I don't work in that sort of way. Basically, I think that if it's got something like that that's faulty, then we need something else to go in its place, which hopefully I'm going to find. Okay. Anyway, that's basically the power supply side of it, and we'll get the power supply side of it working. If that happens, we should get something on the screen, etc. But we'll start with the power supply arrangement here. Looking good. The transformer puts out all the correct voltages in the correct places. The valves all light up. The tube lights up as well, by the way. It comes out here. Look at the bottom, you can see that's lighting too, so that's very much in our favour. L3, the coil, that's fine. The choke, that's fine. And all this here is wired up okay. So now, what we've got to do now is get capacitors to go in there, because like I said before, I don't trust the ones that are in. So 216 microfarads, which I've probably got, and 2 8s, which I probably haven't got. So I'll go and get those tomorrow, and from that we should get the power through to the rest of the unit, which means things might well happen. They might not, but you know, when power comes through to things happen. Sometimes good, sometimes not so good. Now, one thing which you have to be careful of with anything industrial or test equipment or anything of that kind is where the earth is on this, because on this one, first of all, it's a cable through to here, which is this here, and coming out of it, it doesn't actually go to us, as in the case. It doesn't. Actual fact, what it does is the two rectifiers, of course, go to a line on the circuit which is at us, but which is not us. From the case, it goes to the other places where the unit is us, but not to the chassis. So be careful not to go straight to the chassis and say that's this, because it might well not be. Anyway, these two capacitors here are C27 and C28 on the circuit diagram. I'll put it up. I'll put it up for you. There you are. Okay, it's these two here. Okay, so therefore, now they are wired in series. I don't know why, but they are. Now, therefore, this going to here, that going to there, simply puts the two in series. Okay, one end of it goes to the positive line, which I think is this end, which is this end here, and the other end goes to deck. The deck is where all these things meet, so it's here. Okay, so if we now go and stick it all on visible mode, there you go. Okay, but does not go to the case. It goes here, not here, goes here, and not to the case. That's very important to know. Okay, and so this here is one of these capacitors which I think needs to be replaced. Actually, wires going to this also go to deck. Okay, again, I'll leave that for now, and now we know what's where, can find out exactly how to wire it and wire it correctly first time. That is important in a case like this, because if you get something wrong, there could be a horrible, nasty banger no scope anymore. I mean, yes, was one of those things, you know, so they don't go to deck on this, you don't. It's done on the circuit actually. Deck actually is linked in on the primary side of the mains transformer. Linked on the primary side there, but don't seem to be anywhere else. So yeah, so the case therefore is probably it. And yeah, also I'm also taking that capacitor there because the external time method, I don't think so. So that went too well. So anyway, now we put the caps in and bring it up slowly, and hopefully we shall get about 500, 600 volts on there. Now at this stage I've got the power supply put back in with new capacitors, which are smaller actually, but they are the same or about, so that's okay. That was taken out because it was in the way, so I put the smaller one in that should do okay. That's for the sync circuit, by the way. That wire there goes to the switch, it goes to the fuse at the back here, which is currently out. So now all we shall get at this stage is, I hope, heaters. I hope. So that now is going down as the thing warms up, and we should at some point get heaters. If we've not, then I'll there you go. The heaters should be no more than about 6.3 volts, so this will come up down, and it should work, he says. So a quick look and make sure that the well, that one's up, so the heaters look alright. Okay, that's something, and that's the LT sorted. Okay, I'll put that back up for now because I don't particularly want to put power to this, full power to this, with the fuse on, and no way of limiting it. So now I'll find the fuse, put the fuse in, and we'll try again. That's the fuse back in the back, and see what happens now. Again, it's come up like that, but it should come down. And where's your meter? Hang on. I'll have a look at various things that need to be checked here while it's coming up. So I'll just knock it for now, seeing it's not doing anything wrong. And we'll put that onto there like that. Okay. Which is the earth that, as we said, is not the case, but we can check it. Okay. And I will. And if I now put the power back on, AC on here, and see what we get from the transformer. Now, there we are. And this is higher than meter reads there, so the power seems to be doing something. Oh dear, something went bang. Something went bang. Yes, it happens to me too. Happens to me too. Something down here went with a pop. I'll put it back on the limiter and we'll try that again. And we'll look and see what went on, shall we? Heaters are up again. Okay, right, well that still reads okay. Is there anything anywhere else on this thing that yeah. Get the meter and we'll see what we can find on it. Okay, fine, that's okay. That goes to deck. And this side here, look at the circuit. Okay, so there should be something. There are down here. Okay, fine. So it's 500 volts on that. Okay, is that enough to get any light out of it? I wonder. Doesn't look like there is there? Okay, not to worry. Let's have a look and see what's happening on the tube base down here where the problem apparently was. So I'll go in with the meter and see what we find. 200 volts, okay. Is that lit up? It is, yeah, fine, so it's lit, okay. Still not giving us anything, is it? A bit like doing a TV in a way. First thing you look for is what's called first light. There isn't any anywhere. So at the moment it's doesn't seem to have any reason for living in that sort of respect. Doesn't do very much, does it? Right, okay, let's put it back on the charger and have a look on the other side of L3. Okay, fair enough. It's obviously not, obviously the capacitors are working. Okay, right. Well, in that case, we'll put it back on again and see what happens when it warms up. Now, that goes onto there. Okay. Or doesn't. Okay. Doesn't want to, but it's going to. Okay, right, okay, so let's see what's happening somewhere like there. Very, very little, in fact. Very little. Let's try doing that. And again this note. Just make sure that everything else is okay before we okay, that goes on, okay, fine. That tells us absolutely nothing on there. I mean, seriously, nothing. So have I got this power supply wrong, I wonder? It's possible, very possible. And so back on its side again, and again we'll that goes onto there like that. That goes back on. Okay. With that off there, it just drove 500 volts on there. There are. So B should have on it a voltage B on the transformer. What's this got to say for itself, if anything? Let's check it again, make sure it's okay, and then we'll, of course I'll go back to the transformer and see if it has got a fault. If it has, we tried our best. But we have to, at that point we have to leave it or sort out the transformer, make sure that is doing something, or put something else in that will do it. Long wire in the wrong place. is all it took, just one wire. Anyway, first of all, L3 the choke is okay. It goes from there to here, and it's got 500 ohms. It's fine. Okay, so that's okay. Now these have somehow got themselves on the wrong way around, and I don't know what. That actually went to deck, and it took the output from the doubler with it. So yeah, no wonder it went whack. No wonder sparks flew. So back to the old drawing board. One wire in the wrong place, and it led me all the way up that garden path. I built the power supply again correctly this time, and I put a meter on L3 with the choke here, and now we'll see what happens. It's either work or go bang. Which one? Well, there you go. That's on the light bulb now, because I think that in some circumstances I think it might be a good idea to do that. But it's gone down, okay. Aha! There's something there anyway. Don't know what, but there's something on the meter here, and 1.200 volts or so. Okay. So if we do that, then we'll see what, that's going up, okay. And we have a light. We have a light. How about that? We have a light. Well, as you can see there, it appears to be working now. I'm feeding it a signal off my AC generator down there, and as you can see there, it's that's the time-based side of it there, the 10-minute side of it there. That's the time-based side of it there, okay. And that's the fine frequency adjustment there. That's the gain. Volts right here, and it also shows it on the meter down here. Focus, okay. Brightness, not brilliant as it says here. There you go. And so it appears to be working. Well, that is not the full story, because these two smoothing capacitors here, after the power supply and after L3, I'll just put lights. I'll just not that. There we go. And put lights back on and quickly show you the circuit. Now we know that the main transformer is all right. The power supply works. It's these two capacitors here, C27 and C28, which are these two big things down here, which did get rather hot. The capacitors should not get hot. They shouldn't get hot. So obviously they need to be changed for obvious reasons. Well, also I noticed that it did tend to the time base, the horizontal time base, did tend to slow up towards the centre of the screen. Now, looking at how a time-based system works, that is probably because the capacitors on the circuit here are doing things that they shouldn't. You'll see. So I think the one to look at here are probably C8 and C10. It comes off this valve here, okay. So I think the next place we go is taking those two out down there, and of course C8 and C10, wherever they are, they've got to come out and be replaced as well. And now with the unit switched on, which I'm going to do very quickly now. There you go, that goes in like that, and it comes up. First of all, these two capacitors here have cooled down, so I think they've probably reformed, which is okay. So I'm going to leave them for now. As you can see there, if I was to, can you see that? Hang on, I'll just. Can you see that? Okay, that's the display there. That's okay. Now the two caps underneath, again, I've changed those, but I don't want to go much further with this because it is now working, but it only measures up to a meg, which is what do you think that the one here goes up to 20 megs? Then you know there's real not much call for this, but I've fixed it anyway, which is the main thing, and so I'll put it together again and we'll try it again. Well, there we are. David is working away quite happily, and you can operate various controls on it to see what it does, as you can see there and there, like that. Okay, so it does work pretty well now. It's not quite right time-based wise, but this is an oscillograph, not a scope. That means that you can't use it like you can the other scope, because it's for a, is it there? Yes, it is. No, it's not type of arrangement. Anyway, one thing I will note about this very quickly is the power supply arrangement on it. This one has something on it called a voltage doubler. Now, a voltage doubler takes the winding from the transformer, and it has two diodes. This case 2 rectifier valves, capacitors which I've changed, and they're raised in such a way as to double the voltage. That's the idea anyway. Let me put lights back on and knock this off, and I'll quickly take you through it to end the video. Now, first of all, the mains comes in here, and the two diodes are there and there, and of course mains in goes to middle there, and of course the two capacitors there as well. That's the bridge. That's the choke, and that's those two capacitors. Okay. Now then, how does it work? Well, how about that for a bad drawing? Right. Transformer, AC in. Yeah. Now now one of them. Now the middle of it goes to two diodes. There, like that. Okay. Yeah. No connection there, just to there. Okay, so those two diodes, that is the middle of it basically there. Okay, to here, to these capacitors here, and then then here in the middle goes the transformer like that. Okay, and the output of that is twice voltage in. Okay, that's basically how it works. And this is the unit in question. It's an EMI scope, that WM1. The manual is readily available online, and with it only going up to like 1 megahertz, it isn't that much usage apart from possibly audio use, but it works, and so it's something else which is now back working, and so on. So until next time, from Steve's Vintage Radio Longstair Workshop, have fun, and I'll see you soon. Bye bye.